Welcome to Engineering Mechanics tutorial. Today, we are going to discuss about Chapter 2, Resultant of Force Systems. The topics for this session are concept of a force, components of a force, resultant of forces, moments of a force. Of a force. A force is a vector quantity having the following characteristics: magnitude, which is the size of the force; the direction, which is the location where the force is going; the point of application, where the exact location at which a force is applied to a body; the line of action, which is the representation, geometric representation on how the force is applied. It is either a push or a pull that causes a change in the state of motion of a rigid body. So, component of a force, it is the resolution of a force into its horizontal and vertical components. So as you can see here, this is the diagram of the components of a force. As you can see, the vertical line here, vertical arrow, is represented as the F of y, or the force in y-axis. The horizontal line here in the x-axis, this is the F of x, or force in the x-axis. So the red arrow in here is the total resultant force of F of x and F of y, and here this arrow here is the angle of inclination, which is the angle between the F of x and F of y. So in order to get the force of the components, we must get first the formula. So for horizontal components of force F, F of x is equal to F times cosine theta. For the vertical components of force F, F of y is equal to F times sine theta. In order to get the resultant force, F is equal to square root of F of x squared plus F of y squared. To get the angle of inclination that force F makes with the x-axis, tangent theta is equal to F of y over F of x. We can revise this formula and turn it into this formula. Theta is equal to cotangent F of y all over F of x. So, the resultant force. It is the single force obtained by combining a system of force, which is a collection of forces acting on a specified location. So the resultant force is the combination between the F of x or F of y. There are four general types of force systems. First is collinear force system. All forces have the same line of action. As you can see here in the diagram, they have only one line of action. Take note that the forces moving to the right, P3 is moving to the right, are positive, and those moving to the left are negative. So P1 is negative and P2 is negative. So next is parallel force system. Lines of action of all the forces are parallel. As you can see in the diagram, this is an example of parallel force system. So take note that the upward forces, example is the P4, are positive, and the downward forces are negative. So P1, P2, and P3 is an example of negative force. Next is concurrent force system. Lines of action of all the forces passes through a common point. So in the first illustration here, this point here and this point is connected to this point that makes this W, or the block of weight, supported. This cord, again, this cord and this point of cord is connected as one to support this block of weight. Next illustration here is the block of weight W resting in an inclined plane. So P is going towards W, and this is the W. N is going towards W as well, and the F here, friction force, is going towards W as well. So next is the coplanar force system. All lines of action of all the forces line on the same plane. So this illustration here is the plane, and P1 goes here, P2 goes diagonally up, and P3 goes down. So next is moments of a force. The moment of a force about an axis or line is the measure of its ability to produce turning or twisting about the axis. Its magnitude is the product of the force and perpendicularly distance from the axis to the line of action of the force. So moments of a force is more on the ability to produce turning or twisting in the axis. So in getting the moments of a force, the formula is the moments of a force is equal to F times D, where the F here is the force and D is equivalent to the moment arm or perpendicular distance. Next, here is the sample illustration of the moments of a force. This is the F, this is the force, D, which is the distance, and according to the definition of moments of a force, it is the measurement of its ability to produce turning or twisting in the axis. So if the F here moves or rotates clockwise, it is positive force. Then if the F here moves counterclockwise, meaning to say that the force is negative. So that is the end of this tutorial. Thank you for watching.